Hey guys, it's me again, your favorite chemistry teacher. This video is going to be answers to topic 2 for response questions. So yeah, let's get started. Okay, so I think for the 2006 question, I'll probably show my work. The 1997 one I might just talk through with you. Okay, so let's see what's happening here. Okay, so it says suppose the stable element with atomic number 119, symbol Q, has been discovered. A, write the valence electron configuration for Q. So if you take a look at the periodic table, 118 is all the way in the noble gases, so 119 would be underneath francium. So basically what you're going to be doing is, you know that francium's noble gas, or francium's configuration would end in a 7s1. So because it's underneath, all you need to do is write 8s1. And that's your answer. Okay, for letter B, would Q be a metal or a nonmetal? Well, if Q is under francium, it has to be a metal. You can explain in terms of electron configuration because it would have one valence electron, which would make it an alkali metal. Okay. Letter C. On the basis of periodic trends, would Q have the largest atomic radius or the smallest? So you know that going down a group, the snowman, atomic radius goes up. So you would say it would have the largest because it has the most electron shells. So when you add electron shells, shielding goes up, and which attraction will weaken. You don't really have to talk about that there. If you want to, you can. So if you just say largest because it has the most electron shells, which are further from the nucleus. Okay. Alright, letter D. What would most likely be the charge of the Q ion? So since it's a one valence electron, an alkali metal, it would be Q plus 1. E, write the balanced equation that would represent the reaction with water. So you have a metal plus water is going to give you a single replacement reaction. Do not just switch these two. Okay? If you do, you end up with Q2O plus H2. That is not right. Okay, so you want to think about water as HOH. So it would be Q plus HOH. The H and the Q will switch, so it changes your answer slightly. You get QOH plus H2. Alright, now we need to balance this guy. So we'll put a 2 here, a 2 here, 2 there. I think that's good. I can't tell if this is fuzzy. Okay, next one we have letter F. Write the formula for the compound between I and the carbonate ion. So this is not really talking about writing an equation, you're just writing a chemical formula. So Q is plus 1, carbonate is minus 2. Cross their charges, you get Q2CO3. Alright, part 2, predict whether or not this compound will be soluble in water. Because we know Q is an alkali metal, it will be soluble. So because alkali metals are always soluble. Okay. Alright, so let's do 1997. Alright, so maybe I'll just keep it down here. So we have A. Why does potassium have a lower first ionization energy compared to lithium? So if you look on the periodic table for the position of these two, you have lithium and potassium is lower than it. So let's see, what are we talking about? Ionization energy. So first, always relate it, anytime you're describing a trend, always relate back to atomic radius. It's going to be easier. So as you go down, you know atomic radius increases. So you would say something like K has a larger radius than Li because, and you have to be really specific and mention both ions in, or both atoms in your answer. So because K has more electron shells than Li, there will be, this is like the biggest run-on sentence ever, there will be more shielding. So remember, shielding is just when you have inner electrons blocking your outer electrons from the nucleus. So when you have an increased shielding, you have decreased attraction. So think for a minute, if you have decreased attraction, what is your, what is the energy like that will be needed to remove an electron? So if there's decreased attraction, it becomes pretty easy. So energy to remove an electron decreases. Okay, so that should be a fine answer. Okay, part B. The ionic radius of N minus 3 is larger than O minus 2. Alright, so when you explain this, do not explain this with atomic radius trends, because ionic radius is slightly different. So you want to think about, in an ionic situation, how many electrons do both of these have? So, and how many protons do both of them have? So protons 7 and 8. So the negative 3 means that we actually add 3. So we have 10 electrons, 10 electrons. Okay, so now if you know that they have the same number of electrons, the size is going to be completely dependent on the number of protons. So the more protons you have, makes your nuclear charge stronger, so it's able to have more attraction. So if they both have the same number of electrons, and they obviously would not be all on the same level like I just drew, these 7 protons are not able to pull in the electrons as much as an 8 positive charge. I feel like this is really blurry, but I can't figure it out. Okay, so because this pulls in more, this is smaller, and this is larger. So for your answer, I would say something like nitrogen has a smaller nuclear charge than, and you should really put nitrogen minus 3, than O minus 2, with the same number of electrons, which makes it larger. Okay. I'm really sorry if this is blurry. This is a different camera than I've been using. Okay. Let's see. Part C. Alright, a calcium atom is larger than a zinc atom. So calcium and then zinc. So going across. So as you go across, you know atomic radius will go down. So the reason why we're going down is we're going to have an increased, so calcium has a larger size because zinc has a greater nuclear charge, with the same number of electron shells. So electrons are more attracted to the nucleus, making it smaller. This is like really such a mess. Making it smaller. Okay. You can also think about, like, it's kind of confusing because when you have a transition metal, electrons are being added to an inside shell, which isn't going to affect it very much. So going across, you really want to just consider number of protons. That's what's going to make the most difference. Okay, letter D. Okay, boron has a lower first ionization energy than beryllium. So it's not supposed to. So according to trends going across, ionization energy should increase. So when you get one that has you describe like an exception to the rule, what I would do is write their electron configuration. So Be is 1s2, 2s2. B is 1s2, 2s2, 2p1. So I think it becomes easier to explain if you can actually see what the configurations are like. So normally B would have a higher ionization energy, but if you look at your choices, see how this Be has a full 2s sublevel? This one has a full 2s sublevel, but it also has just 1p electron. This 1p electron is going to be able to be removed easier than removing from a full sublevel. So you could say something like that. You could also say the 2s electrons in boron shield the 2p electrons, making attraction decrease, lowering ionization energy. And you should somehow work, and then you could say like, so boron is less than beryllium. Alright guys, until next time.